Miller's anatomy might be wrong. They say the distal tendon passes through the carpal canal, but this may not be the case. Where does it go and how does it get to its insertion on the metacarpals? We'll be figuring this out. The flexor carpi radialis is located on the medial side of the dog's forearm or antebrachium. It's a superficial muscle, which means that it lies directly under the skin and under the antebrachial fascia. It originates here on the medial epicondyle on the humerus, just caudal, just behind the medial collateral ligament of the elbow. Its origin sits between the pronator teres, which lies in front of it, and the tendon of the flexor digitorum profundus behind it. From the medial epicondyle, the muscle extends distally down the forelimb, running between the pronator teres in front of it and the flexor digitorum superficialis behind it, and it covers the flexor digitorum profundus, which is deep to the flexor carpi radialis muscle. The flexor carpi radialis is short, thick, fusiform. Fusiform meaning the muscle is spindle-shaped and the fibers run parallel. Though this muscle is relatively small, it's still about twice the size of the pronator teres that lies in front of it. Around the middle of the radius here, the muscle merges into a flat tendon that continues down the medial antebrachium. It's supported throughout from fascia that comes from the radius. As the tendon down here reaches the flexor side of the carpus, it passes near, but not through the carpal canal. So this is where Miller's anatomy, however, describes the flexor carpi radialis as being within the carpal canal. I found their definition of the carpal canal itself and its borders to be vague. So I went to other anatomy texts and they did not all agree on the definition of the area of the carpal canal on the palmar side of the carpus. Apparently I wasn't the only one who found this lack of congruence frustrating. I found that in 2022, a team of researchers in Spain looked at this area in detail in a paper titled Anatomy of the Palmar Region of the Carpus of the Dog. So this here, I've drawn the palmar side of the carpus of the dog. So this is going to be the left carpus. This is the medial side, and this is the lateral side here. So this is the radius. This is the ulna. This is the ulnar carpal bone, accessory carpal bone, intermedial radial carpal bone, or we can just call it the radial carpal bone. First carpal, second carpal, third carpal, fourth carpal bone. And here we have the first, second, third, fourth, and fifth metacarpals. In this paper, they define the carpal canal as a space that is bordered on the dorsal side by the common palmar ligament. Remember, this is the palmar view, so the dorsal side is going to be closer to the bones, closer to the carpal bones. They define this space on the palmar side toward us by the deep part of the flexor retinaculum. So the flexor retinaculum has two parts. This is the deeper part. They define the carpal canal border laterally by a thin, dense band of collagen fibers coming from the deep flexor retinaculum to the common palmar ligament, connecting those two structures together. And they define the border on the medial side by the antebrachial fascia running down and connecting into the common palmar ligament and the deep flexor retinaculum. So this medial wall is what separates the flexor carpi radialis from the structures inside the carpal canal. The carpal canal itself contains the flexor digitorum profundus muscle, the interflexius muscle, the median nerve, the median artery, and the median vein. It does not contain the flexor carpi radialis, however. The flexor carpi radialis passes medially against, but not within the carpal canal. So the carpal canal will be about here, and the flexor carpi radialis tendon will pass medially against the canal itself. The flexor carpi radialis tendon is enclosed in its own synovial sheath, which begins down here, or I should say up here on the distal radius, and continues down nearly to its insertion on the metacarpals. The tendon continues distally, again, on the palmar side of the carpus. At the carpo-metacarpal joint here, the tendon of the flexor carpi radialis splits into two tendons, as you can see, which insert into the proximal palmar metacarpals 2 and 3. The median nerve is the nerve that innervates the flexor carpi radialis. The primary action of the Flexor Carpi Radialis, as you might have guessed, is to flex the carpus. However, this isn't all that it does. In a paper from 1993, Latour and colleagues proposed this muscle has intramuscular specialization. This means that different parts of the muscle may have different functions. They found that the radial portion of the muscle contains more type 1 or slow twitch fibers, suggesting that the radial portion of the muscle plays a bigger role in stabilizing the forelimb and maintaining posture. The cubital portion of this muscle had fewer type 1 fibers and more fast twitch fibers, which are built for quick, powerful contractions. The researchers proposed that this part of the muscle contributes more to carpal flexion during locomotion. This dual structure may help to explain some interesting findings from a 1973 EMG study, which recorded electrical activity in the flexor carpi radialis during the late swing phase and the first half of the stance phase. That's when the dog is nearly ready to put its paw down, puts its paw down, and the first half of the stance phase when its paw is down. So what's surprising is that during these phases, the carpus isn't actually flexed. So why is the flexor carpi radialis muscle active at this time? One theory is that the flexor carpi radialis functions as an antagonist to the carpal extensors, helping to stabilize the joint when the carpus is extended, especially during weight bearing in the early stance phase. Another possibility is that it contributes to cranial thrust, a little push forward later in the stance phase. Interestingly, this muscle produces less force and performs less work than other carpal flexors, like the flexor digitorum superficialis, flexor digitorum profundus, and flexor carpi ulnaris. This supports the idea that its primary role may not be force generation, but stabilization, particularly during high-impact actions like landing from a jump. Although it likely plays an important role in stabilization, I couldn't find any published reports of sporting dog injuries directly involving this muscle. I'm sure they occur in carpal dog injuries, though. Its cousin, the flexor carpi ulnaris, will be next.